Hi, my name is John Corral, and for today, I'll be discussing a statically indeterminate beams using the area moment method. So, we'll be using the area moment method. Okay, so let's first analyze our problem for today. So as you can see, this is a statically indeterminate beam. So paano natin malalaman kung isang problem ay statically indeterminate? So according to facts, these are problems that are not solvable using three equilibrium equations. So ano tatlong yun? These are the moments, the f of x or the horizontal forces, and the f of y, which is the vertical forces. Kung mapapansin nyo sa ating problem, puro siya vertical forces. There's no horizontal forces sa baba. So, kaya ko masasabi na ito ay statically indeterminate. So, moving forward, we have, since this is a cantilever at point A, there is a reaction that goes upwards. So, let's put RA, which is reaction at A. And since this is a roller at B, there's also a force going upwards, R of B. And always remember that going upwards, the upward direction is always positive. And going downwards is negative. So, we have reaction of B going upwards, we have 50 kilonewtons going downwards, and we have a uniformly distributed load of 20 kilonewtons over meters going downwards, and we have the reaction of A going upwards. Since we have A, let's classify this as the moment center. But first, bago tayo mag-classify natin yung moment center, kailangan natin piliin ang moment center where the point kung saan tayo pwede maka-eliminate ng marami. So, kung makapansin nyo dito sa ating problem, alin ba dyan ang point na pwede tayo maka-eliminate ng marami? Is it B, B, C, or A? So, halata naman na A is the point where you can eliminate the most. So, let's classify point A as the moment center. And moment center A going counterclockwise direction. Moment of A. Okay. So we have now thoroughly analyzed our given. So to continue, we need to continue the moment diagram by parts. So let's start from B. So, since RB is going upwards, it's going in a positive direction. So, let's draw an inclined triangle to visualize in our diagram. Visualize it. So, the inclined triangle that goes upwards with respect to our moment center goes along the point B, and it's positive. It is positive. Okay. So, point B, since we have RB, this is just force times distance, or distance times force. It's just the same. And all over I, which is our constant that we will be using for today. Okay, so gagamitin natin lagi yung constant yun. So, anyways, i-eliminate din naman natin yun pagdating sa solution part. Okay, so we have force and distance, this times our force. So we have 5 meters. It's R all over our constant of EI. Next, we have D goes downwards. So our inclined triangle will go downwards. Okay. Okay, so since it's 50 kilonewtons times distance, 3 plus 1, so 4 meters. So 50 kilonewtons times 4 meters is equals to negative 200 kilonewtons times meters. Why is it negative? Since it's going downwards, again, it's negative. Okay, so negative 200 kilonewtons times meters all over EI. Okay, now let's go on our point C. So point C now is also pointing up downwards. So since it is a uniform distributed load, we'll be using a parabolic one. And since it's going downwards, it's also going downwards. Parabolic. So again, since this is a uniformly distributed load, so it's 20 kilonewtons over meters times the distance, 3 meters, times the half of it, since it's a uniformly distributed load. So the half of 3 is 1.5, so it's 20 kilonewtons over meters times 3 meters times 1.5 meters, and the answer will be negative 90 kilonewtons times meters. Constant of EI. Okay. Now we can classify our diagram since this is an incline. So it's the first incline, our first degree is first degree, and the parabolic one is second degree. Always second degree. Okay? So second degree, first degree, first degree. Okay. Now, before we move on to our problem solving part, let's analyze more our given. Okay, para mag-visualize natin paano mabuti ang ating problem, need natin gawin ang ating elastic curve. Ano ang elastic curve? So, ang elastic curve, yun na ay para ma-visualize natin ang ating beam kung paano siya mag-bend depende sa forces na nag-a-act sa kanya. So, since marami tayong forces sa pababa, so in-expect natin na pababa yung elastic curve. Since doon tayo, yun yung in-expect natin. Kumbaga, binivisualize lang natin kung paano yung bending ng isang beam. Depende sa forces na nag-act sa kanya. So since this is a cantilever, we'll start from 0. So our elastic curve will be like this. So it's now going downwards. And again, now it also goes upwards again, going to 0 since we have a roller on B. Okay, so that is our elastic curve for the problem. And next, we need to use the relation of tangent deviation. So to find the tangent deviation, we must first find the elastic curve. So now we have found the elastic curve. Now we need to find the tangent deviation. So to find that, just need to draw a line that touches the elastic curve. Just this. Okay. This will be tangent A. Okay. Tangent of A. So now we have thoroughly analyzed our given, and I can say that we can move now to our problem. So before I move on, let's first find what is being needed. So as we all know, we have one unknown here, which is RB. And in fact, the things that we need to find in our problem is the reaction of A, the reaction of B, and the moment of A. Since in our diagram there's only one unknown, this will be the first that we need to find. So our required will be reaction of A, reaction of B, Get set, go.
Go.
So, we can now move on to the solution part of our problem, since we now thoroughly analyzed our given. So to start with our solution part of the problem, okay, solution part. So since we have a tangent of A and it's close to B, so we have a tangent deviation of B, tangent deviation of B with respect to A, which is equal to 0. O bakit siya equals to 0? Kasi nga, kanina, i-explain ko, we started from a cantilever, which is 0, and ended with a roller, which is also 0. So, the tangent deviation B with respect to A is equals to 0. Okay? So, yun yung question. Tangent deviation B with respect to A is equals to 0. Okay. To find our unknown, which is the reaction B, we need to use this formula of area, the area of B of A, area BA, under, times the centroid with respect to B. Okay, and since mapapansin natin lahat sila may constant na EI or 1 over EI, so pwede natin sila i-cancel and just write this, 1 over EI. Kumbaga, i-factor out na natin sila. Factoring out. Okay? So, we can now solve our problem starting with this by looking at our diagram. So, we'll start from area. Oh wait, before I move on, as we all know, the area of a triangle is 1/2 times base times height. And the area for things like this is 1/3 times base times height. So, starting from this, we start from 1/2. So it will be 1/2 times the values. Yep, so it's 5 meters, it's the area. RB times 5 meters. Height times base. Okay, so we move on now to the center. So it will be 2/3 with respect to B. Since it's this center of this shape with respect to B is this. So it's 2/3. 2/3 times base 5 meters. Okay? So minus, since this is negative, so it's minus 1/2 again. It's 1/2 since it is also a triangle. Like, okay, so times base times height, height times base is the same. So 200 kilonewtons times meters times the base of 4 meters. Okay, and for the centroid, since we have a distance of 1 meter here, so we will add 1 meter plus. Now for our centroid, is the centroid of this shape with respect to B. So it will be again 2/3 times 5 meters. Oh, it's now 4 meters. Since the distance of this is 4 meters, this one is 4 meters. So it's 4 meters times 4 meters. And lastly, for this one, for the parabolic one, minus again, since it's negative, minus 1/3 times 90 kilonewtons times meters times the base of 3 meters to 2 meters plus centroid of 3/4 times distance 3 meters, and that will be the one that we are solving. find the RD, the reaction P, need lang natin i-isolate ito from the rest para makuha natin ang RD. So it's just transposing of values to the other sides para ma-isolate ang RD. So, sulit ko pa rin yun. By transposing it, ilipat na natin ito, sama to sa kabila. So, it will be written as this. 1/2 times 5 meters RD times 2/3 5 meters equals, since we transpose this, it will be now positive 1/2 times 200 kilonewtons times meters times 4 times 1 meter 2/3 4 meters. Okay, since now this is positive, it's now plus 1/3 90 kilonewtons meters 2/3 plus 3/4 meters. Now we have this one. Okay? By calculating these values, we get an answer of 41.667 meters cubed. It's meters cubed since oh, I forgot to write this. So it's 1/2 times 5 meters RD times 5 meters. Okay. So it's meters cubed since meter times meter times meter. It's meters cubed. So by calculating these values, we get an answer of 41.667 meters cubed. The one that we are. Okay? So by calculating these values, again, we'll get an answer of 1,849.167. And it's kilonewtons times meters cubed. It's kilonewton times cubed since kilonewton times meters times meters times meters. Kilonewtons times meters times meters and times. Okay? So, for the final part, transposing, we need to transpose this value to the other side to isolate finally the reaction of heat. So, transposing that, we get a value of 1,049.167 kilonewtons times meters cubed, all over 41.667 meters cubed. Okay, we just need to cancel this out since it's just the same. So now calculate the value of our reaction of heat. Okay, so by calculating these numbers or calculating these values, you get answer of 44.37965.296 kilonewtons. Okay, so by just rounding it off to 2 decimal places, we'll get an answer of 44.38 kilonewtons. Now we have an answer for our heat. Okay, this is the answer for our heat. So I'll just write here. The answer for RB is 44.38 kilonewtons. Okay? So, erase ko muna yung part kasi tuloy ba ang solution ng mag-calculate. So, remember the answer, 44.38 kilonewtons, and this is the solution for it, to find it. So, we'll back. So the next one that we're going to find is the moment of A. Moment of A. So moment of A going counterclockwise direction is positive. A going the counterclockwise direction. Moment of A is equals to 8. So, moment of our moment center, which is 8. So, moment of A plus 44.38 kilonewtons. It's positive since it's going upwards. Times the distance with respect to A. So, it's 3 plus 1 plus 1, which is 5 meters. Again, minus 50 kilonewtons since the force is going downwards, it's negative or minus 50 kilonewtons times the distance of it from A, so 3 plus 1 is 4 meters. And lastly, minus 20 kilonewtons since it's going downwards. And since this is in this uniformly distributed load, it will be 20 kilonewtons over meters times the distance of it, so 3 meters, times the distance, half distance, which is 1.5 meters. So by cancelling the units, it will be like this. Okay? Okay, it's equals to 0. And now, we just need to isolate the A, MA. So we just need to transpose these values to the other side. So it will be moment of A is equals to now negative 44.38 kilonewtons times 5 meters plus, it's now positive or plus since transpose it, meters plus 20 kilonewtons, meters, 3 meters, 1.5 meters. Cancel. Now, by calculating these values that I nakuha ko, we will get final answer for moment of A of 68.10 kilonewtons times meters. Going in counterclockwise direction. So this will be moment of A. Now, kuha natin ang ating moment of A. And lastly, to complete our problem for today, kukunin natin ang ating reaction of A. And itong part ito ay madali lang. Since halos lahat ng forces na nakuha natin, nag-iisa na lang siyang reaction of A, or nag-iisa na lang siyang vertical force na ating nahanap. Since we have now RB and we have down force, which is given and is also given, hanap na RA, so it will just be the summation of vertical forces or the summation of, which is the summation of F of Y. Going in upwards direction is positive. Okay? So, it will be now reaction A, hinahanap natin, plus 44.38 kilonewtons, since going upwards it's positive, minus 20 kilonewtons over meter times 3 meters. So cancel out the meter unit or the unit of meter, right? And also minus 50 kilonewtons since it's going upwards. So 50 kilonewtons equals to 0. So, gano'n lang tayo na sa ating pag-solve ng moment of A. Ito-transpose lang natin ito, yung mga values para ma-isolate natin yung reaction A. So, transpose again, it will be now negative 44.38 kilonewtons plus 20 kilonewtons over meter times 3 meters plus 50 kilonewtons. Okay? So, by calculating now those values, we will get an answer of 65.62 kilonewtons. 65.62 kilonewtons. Which goes the upwards direction is positive. Okay. So direction A, 65, 62 kilonewtons. So we have now completed are required for this problem. So, these are answers. These are our answers for the problem. We have the reaction B, which is 44.38 kilonewtons for the amount of A, which is 68.10 kilonewtons times meters going in counterclockwise direction. And we have the reaction A, which is 62.65, which is reaction A, which is 65.62 kilonewtons going the upwards direction, which is positive. So that will be all. Thank you.